Hi, I'm an old guy and I do maths, and today we're into geometry, particularly circle geometry, and we're looking at angles in a circle, something that I know as Theorem 1 from circular geometry. And I'm going to read you the explanation of this from my book, and then I'm going to translate that into something understandable. So the angle subtended at the center of a circle is twice the angle subtended at the circumference, standing on the same arc. Well, that's a bit of a barrier to understanding. So what does it mean? It means that if this is the center of the circle and this are radii going out to the edge of the circle, to the arc of the circle, then this angle here will be 2 times the size of this angle here. So if this is 10 degrees, this will be 20. And this is a very handy rule, especially when it comes to solving geometric problems. But it's not something that is always immediately obvious. Sitting here like this, it's pretty easy to see what it is you're dealing with. But I'd like you to have a look at a couple of, well, 3 at least, other drawings that I've made. Now these are a bit rougher than that because I just sketched them up. But here's the center of our circle, and we have our 2 radii going out to the edge of the circle, and they meet the circle here. So we have the first part of this. Now, when we look at this line, it heads off to the edge of the circle, as does this. But what you saw in the initial diagram was something that looked a bit like that, and it's really easy to see. It's harder to spot that this might be 15 degrees and this angle in here might be 30, but in fact they are, because we are dealing with exactly the same set of circumstances. We have 2 radii going out to the edge of a circle. From there we have some lines drawn to the edge of the circle somewhere else on the circle where they meet. And that is all that's required for this rule to hold true. Here's another example. Now, this really doesn't look like what we've been dealing with, but again, center of the circle, radius, radius, line from that point to the edge of the circle, and it meets this line here. So let's say that this is 30 degrees. This will be, oh, that's more than 30 degrees. Let's say that that's 60 degrees. This is probably 120 degrees. For exactly the same reason. Again, look at this. Look at this. They look quite different. And here's another. This is by no means exhaustive. This may well be hard to see, but we have the center of a circle, a radius, and lines drawn that meet here. It might be easier if you looked at it that way. And I think you can see more clearly that it at least resembles that. So what do we say about this? Well, it's a puzzle, as is much of geometry, and the best way to approach it is to treat it as a puzzle. So you might, for instance, be looking at this like this for 10 minutes and scratching your head. It always pays to look at things from a slightly different angle if you can. And sometimes then they make sense. Imagine, for instance, that you're looking at this from this perspective. that's quite confusing, I think. I don't know about that. Maybe that is, maybe that isn't. But the point is that really what you should go looking for, and I'll use this one here as an example because it was designed to be the most perplexing. You're looking for a number of characteristics. 2 radii from the center of the circle, and the ends of those radii connected to one other point on the circle by 2 lines. So we have 1, 2, 3, 4 lines, and 1, 2, 3 points on the arc of the circle, and the center of the circle. And those are the characteristics that you're looking for. Okay, well, thank you very much for watching. If you found this useful or interesting, or both, please remember to like this video and subscribe. There's new content coming up all the time. Thanks. See you again. Bye.